Well, hi everyone. Thanks for showing up for your learning. I have count them, two exponential functions questions for you that have not been very well answered. These are question types. I created these questions. It took me about 3 minutes to create these questions and 3 minutes to discuss these questions with my daughter. But here we are. She's here, I'm here, she's eating a sandwich. I'm doing math. My sandwich is eaten. All right, so here's the situation. In 2010, I had 99 problems. You know the rest of the song. But in 2023, I have 1,234 problems. My problems have multiplied. My problems have grown exponentially. At what percentage rate are my problems growing per year? Okay, this is not that easy. Okay, I appreciate it's not that easy. So this is how I would set up this situation. I would say this is my A initial value. My goal is percent rate. What's the B? That's what I want to find. This is time equals 0. This is time equals 13. Why? Because that's 13 years after my problems passed the 100, went 3 digits. That's like when I had 3 digits worth of problems. All right, so let's find out at what percentage my problems are growing each year. This is how I would do it. And this is how I want you to do it because it's correct and it's easy. All right, so here, I know that problems is a function of time and it's equal to the initial number. I'll do a really boiled down algebra one. The initial number of problems multiplied by the growth rate multiplied by time. That's the base function. Okay, but I have one of these values, one of them. Problems at time 0 was equal to 99. So I can just use that as the A value. Okay, and then I also know that the number of problems that I have after 13 years is equal to 1,234. Who comes up with these numbers anyway? Which is also equal to 99 multiplied by whatever B is raised to the power 13. So let's solve for B, shall we? Because that's our goal, is to solve for B. So how would we do it? Well, we get out our inverse operations pen and we divide both sides of this equation by 99. I don't happen to know how to divide 1, 2, 3, 4 by 99 in my head, so I do that on a calculator. 1, 2, 3, 4 divided by 99 equals, oh, of course it's 12.4646464646. Who didn't know that? Who didn't know that it was 12.464646? So we'll write that down. 12.46, I could have changed pens, repeating, is equal to b to the 13. Kind of wish I did change because now I want to do this super sweet, awesome inverse operation that's going to solve this for us. If I know that b raised to the 13th power is 12.46 repeating, then I could do this one of two ways. No, I don't want to use a rainbow pen. Thank you very much. Give me a hint at what one of my 1, 2, 3, 4 problems is. Is people suggesting, hey, how about a rainbow pen right in the middle of your flow? You know, when you're in the middle of your algebra flow, and someone's like, rainbow pen. You know, that's not what you need to progress the problem. All right, let's keep going. It's good to laugh about these things, right? It's good to laugh. Okay. All right. So we have this 12.46 repeating is equal to b to the 13. Well, if I told you that 4 was equal to b squared, probably 99 of you, and the one of you who wouldn't, 99 out of 100 of you, and the one who wouldn't is one of my problems, would say you just take the square root of both sides, Mr. Jennings. Okay. Now here we don't take the square root, we take the 13th root. Oh, I wanted to do that in another color because that's an inverse operation. This is another case of funny once, not funny twice. Okay, so here we go. That effectively clears away that 13 and solves it for you for B. It's not getting funnier. So B is equal to, well, we've got it here. Let us take the, and now see, so I'm kind of lost here. I've got to go second function and then do the, I think I type it this way, 13th root of 12.4646464646. And for those of you who appreciate my commitment to accuracy there, you know, we salute one another. Okay, so it turns out that they're growing at that like every year. How does that need more salt, man? Your salt is growing exponentially. Like really, there's more salt than egg. Oh my goodness. We'll stay home, they said. We won't be any distraction, they said. Okay, here we go. Okay, so this is 1.228, I think I saw. Yeah, 84, yeah. So this is 1.223. So 1.23, oh, that's cool. Okay, it's approximately equal to B. That's equal by rounding. Okay, so therefore, my problems grow by 23% per year. That's how you do that. You take the 13th root of both sides. Now there's another option, and I like it better because it doesn't involve me staring at my calculator, figuring out how to take the 13th root of stuff, and that's raising things to the 13th power. When you've got this, b to the 13 is equal to 12.46 repeating, you just take that, let's just raise this to the 13th power, and we'll get 12. What? I don't understand. Why did that do that? Did I not type the right thing? Oh my goodness. The 13th root of, I bet I did the 12.46 root. It's not correct. It's not correct because I don't know how to use that calculator to take the 13th root of things. Why? Because I do things in a different way. The better way. Let me show you the better way. Oh, that's frustrating. So now you know where another one of my problems comes from. It's from getting calculators to cooperate with the algebra I want. Here, an inverse move I can use is raise both sides to the 1 over 13. This will give you b to the 13 over 13, which is a very fancy way of saying b to the 1, which is to say I've solved for b. So let's go. If we have 1, 2, 3, 4 divided by 99, gives us this beautiful number. And then we raise that to the, put it in brackets, 1 divided by 13, and the brackets, we'll get a different number. There we go, 21%. That's the correct number. That's the percent that my problems grow per year. Okay, so B is equal to 1.214. Okay, so therefore, my problems grow at 21% per year. Now you're young. This should scare you. Okay, so it's like, you got one problem this course. Don't worry. Next year you'll have 1.21 problems. It's not kind. It's not kind of me to laugh at you because you're young and you don't know what's waiting for you around the bend. Okay, let's keep going. No, wait, Mr. Jennings, we want to see you check your answer in Desmos. Okay, sure. Okay, fine. I will oblige you. I will always, of course, be happy to check my answer in Desmos. Let's see if this function, 99 multiplied by 1.21, whatever the rest of that number was, because we want a little bit of accuracy here, 21418. 21418 raised to the power x. Okay, and now let's look at, we want to see 13 years in the future at least. We don't care about years in the past. Well, maybe that'll be interesting. That'll be fun to see. And we definitely want to see up to about 1,500 problems. All right. So let's see if we bullseyed it. Okay, I want to know, where does y equal 1, 2, 3, 4? Right there, 13 years. So this is perfect. This works. This function works. The growth factor is correct. And you see 1.214, and you know that means 21.4% growth because you've been doing the work and you've been following along with the lessons in the D2L, right? If you don't know, send me an email, and then I'll know that you have this question and I can help you. Okay, let's find out how many problems I had. This is 2023. So this is 2000. No, this is 2010. Okay, so I want to go back in time to 1995. So that's back at -15. Back when I was your age, I had exactly five problems or so. Sounds about right, actually. Okay. All right, cool. I think it's cool. You may not find it cool, but I find it cool. All right. New question. Let's talk about these Billie Eilish fans. This is much more cheerful. Okay. No, I'm cheerful. I'm laughing about my problems. I don't have any serious problems. I'm very grateful for my life, actually. I'm very grateful for all the things that I have. And I'm grateful for many of the problems that I have. Little girls that tell me that I should be using a rainbow pen in the middle of my videos is not the worst thing that could happen to somebody. Very grateful. Okay, let's keep going. Initially, there were only 15 Billie Eilish fans. Like she was like really popular in a very small group of people. 15. Okay, initially there were that many. They grew at 10% per day. Oh, very good, Billie Eilish. You're getting very popular very quickly. Okay, so let's build a function here. This is A is equal to 15. There's 15 initially. This is my rate. My growth rate is 0.10. That's 10% as a decimal. So my B is going to be equal to 1 plus R. So in this case, it's 1 plus 0.1. So it's 1.1. That's B. And now I've got everything I need to make this function. Okay, so the number of fans, capital F, is a function of time, f of t, is 15, the initial value, multiplied by 1.1 raised to the power time. And now we want to know, when will there be this many fans? Okay, how many days will that take? 150 million fans? Wow. Okay, here's what I've seen some of you do, and it's very, very wrong. Okay, it's very, very wrong because it doesn't work this way. I see you do this. You write out 150,000,000 is equal to 15 times t or something like that. I don't know what you're doing. Times 1.1 to the t. And then you divide both sides by 15. And then you get the answer 10 million. And then you say, okay, 10 million days. Sorry, no. No, it's not. It's very not 10 million days. 10 million days is like quite a lot of time. It's like more than human history. It's more than recorded history. And Billie Eilish got famous a lot faster than that. So let's see how we solve this. Notice that this does not say equals t. It says equals 1.1 raised to the power t. That's different. So others of you then get here and use logs and solve it. Congratulations, you jumped the queue and went and learned a grade 12 skill. Great, that will serve you well next year. This year we teach you graphing and guess and check. I'll show you graphing first. So here we go. Bloop, bloop. We need fresh Desmos. We are going to say, here's our function. 15 multiplied by 1.1 raised to the power x. Why not t? Well, because Desmos recognizes x as the x values, okay? That's why. And then we want to look at a big number, a big amount of time. So let's first put in, for our y value, we want it like, say, 200 million. I just like getting the value. That's 1, 2, 3, 4, 5, 6. Well, it's just 2 million. I need two more zeros. There we go. That's 200 million. Okay, boop, there it is. 200 million. Okay. Oh, but it's still way down there, Mr. Jennings. We want it to be up here at y is equal to 150. Oh. There it is. That's the number of fans she has. About half the population of the United States. It's a large number. I don't know if I think she does have that many fans. This is like craziness. Okay, anyway. So let's look at more and more values of x until we see the graph hockey stick up. This is exponential growth, folks. Here's 200 days. Still not there. That's like less than a year. Okay, 2,000 days. Oh, we got it. It's just a little past 200. Cool, eh? Yeah, it doesn't take that long. Does not take 10 million days for Billie Eilish to become popular with this kind of growth. Okay, that's a lot of growth, 10% per day. That's very fast. Okay, so let's try and just kind of guess it. It's about 500. Oh no, it's even before 200. I just wasn't seeing it. It was underneath the screen there. So 200 will do. Boop. Yeah, there. Should take about 169 days. Okay, that's actually a little faster than I wanted, but whatever. Still gives you an idea that you can't see the growth until suddenly it's all over you. All right, so let's go. Let's do the work. How would we do this without Desmos if we were doing this on, like, say, an exam? Well, at this point, once I've divided this away, I've actually isolated this algebraically as much as I can without some fancy grade 12 tricks. So what I can do now is create a little chart, a t-chart, right? And I'm going to do values of time and values of 1.1 to the time. And I get this out and I say, I don't know, maybe I think it's going to take her 50 days. 1.1 raised to the power of 50 is equal to 117. No, she'll have 117 times the number of followers after 50 days. So T50, I got 117. Not even close. So I guess way bigger. And I guess 500. 1.1 raised to the power of 500 is equal to, oh my goodness, that's an astronomically big number. Okay, let's count. Thousands, millions, billions, trillions, quadrillions, quintillions of fans. Okay, quintillions of people does not exist so far as we know. Quintillions of life forms probably don't exist. That's just an enormous number. So 500 too big. Okay, and now I'm going to guess. Okay, I need to guess a little smaller. I'll just guess about 200. 1.1 raised to the 200. Well, that's a lot closer, isn't it? Okay. So 200 and I get 190 million. Going to round to the nearest million. Yeah. 200, 190 mil. Very good. Let's guess 170. It's too small, but let's guess. 1.1 to the 170 equals, oh, that's only 10 million. I'm going to guess bigger. It's like 11 million. So we want bigger than that and quite a bit closer to 200, I would say. So let's do 1.1 raised to the 190. Well, that's pretty darn close, 73 million. Let's do 195. 1.1 raised to the 195 equals. Really, really close. 195 is 1, what was it? 18. Oh, I'm over. I only want it to be equal to 10 million. I was aiming for that number. Ha, 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 making a mistake. And you guys let me keep going. This was actually really close, wasn't it? 170. Okay, I was getting a little confused there. Okay, 170. So 170 is the number that we're looking around. So let's try 169. I think I remember it was, in fact, exactly 169. 1.1 raised to the 169 equals, yes. Very, very, very close. And then we could even refine our guess. 169.2. Let's try 169. 0.2 days. Like a fifth of a day into the next day. 1.1 raised to the 169.2 equals, very, very good. We're only out by 85,000. times the number of initial followers. So that's how you would answer this one. Therefore, it takes Billy, is it Billy or Billi? I don't know. It takes Billy about, the nearest day is fine, 169 days and a handful of hours to achieve 150,000 followers. Fans. I said fans. Okay, so that's how you'd solve that type of problem. This is a much longer video than it needed to be, so I really appreciate your patience and sticking with me on this problematic day of sorts. We're seeing a lot of problems today, and happy to explore the solutions with you. If you have any questions, send me an email. Otherwise, keep on math and math team.